guys, welcome back to my channel. This is Notepal. Today's subject is digital design and DDCO. Okay, and today our topic was based on a research paper. So we were going to talk about the research paper. I might add the research paper on the link or description below. So if you want, you can check that out. For now, let's move on to the slides. Uh, so, uh, Today's topic is accelerated and highly correlated ASIC synthesis of AI hardware subsystem using CGP. So, ASIC is application specified integrated circuit. So, uh, how is this topic related to DDCO? Basically, ASIC are customized hardware circuit designed for specific tasks. Okay, so in digital design, creating ASICs involved defining the logic, behavior, and architecture of the hardware. This topic involves AI, as I said, using CGP, which refers to Cartesian Genetic Programming. ASIC design is a part of digital design and it follows principle of logic gate design, timing analysis, and low power design, which is the core concept of digital design. Uh, so that's what basically is, and so let's move on today. So introduction and motives of the research was efficient hardware. Traditional ASIC synthesizer follows struggles to efficiently realize nonlinear functions such as activation function and power function commonly used in AI models. Unconventional function. This function, due to their inherent complexity and non-linearity, are difficult to map to standard cell and require unconventional synthesis methods. Bottleneck. For AI hardware, this can be can be a significant bottleneck. Efficiently when especially while de- dealing with functions such as nonlinear activation function in neural networks. So problem statement was lack of design space, synthesis time, and some robotic design. Uh, existing do not provide adapt mechanism for exploring different design configuration to find optical optimal hardware realization of complex functions. That was lack of design space. And synthesis time means the time taken to synthesize this function use standard flow in is high as the tool tries to map nonlinear functions to standard gates. So it takes time, and some for female design, often this design product produced by traditional synthesized methods are some for female in terms of hardware parameters like gate count, area, delay, and power consumption. So proposed approach was CGP. This research introduced a synthesized flow that incorporates CGP to overcome this limitation. CGP, an evolutionary algorithm, allows the explorer of a wide design space to identify a hierarchical gate level design that are efficient in terms of hardware resource utilization. And design space exploration was CGP can explore various design configuration involving from one design to another in search of most efficient solution. Custom gate incorporation allows us to use of custom logic gate tailor for a specific function that function being synthesized improved it which improves the efficiency of this system. Parallel synthesizer CGP is particularly useful for parallel parallelising parallelizing the size of complex function by evolving multiple design conditions simultaneously. Hierarchy synthesis framework was CGP evolution, starting with a predefined list of logic gates, basic and compound gates like X NOR, AND, OR, NOT, NOR, MUX, etc. CGP evolves gate level design that matches the design of non-linear function. Fitness evaluation. Fitness function in CGP evaluation, how closely the evolved circuit matches the expected function. This considered both function correction, matching the truth table, and hardware perform matrix like area, delay, and power. Integrating with ASIC flow. Once the CGP evolves an optimal gate level design, the hierarchical list is flattened and incorporated into standard ASICs synthesized flow. This allows the final hardware parameters to be extracted. CGP RT, the number of inputs each gate is in the circuit can have. The set of logic gates available for constructing circuits, function set. Mutation rate. CGP use mutation as a primary operator to evolve the circuit in proposed method. An explorational vary mutation rate is used to accelerate the convergence of the algorithm. Fitness function. The fitness function is based on how well the evolved circuits perform the desired function as well as how efficient it is used to hardware resources. CGP enhancement. So, various mutation rate EVR. The mutation rate in traditional CGP is constant throughout the evolution process, which leads to show convergence, especially for complex function. In this work, an exponential varying in mutation rate is introduced. Uh, Excuse me for my pronunciation, it's a little off today. Uh, um, Binary weight fitness. In standard CGP approach, the fitness function gives equal weight to all bits in output. However, for many functions, especially in AI, errors in the high order bits are much more significant than errors in low order bits. So yeah, binary weight function just says that it gives weight to every function. However, for many functions, errors in high order bits are much more significant. So yeah, it just gives a little bit preference to higher bit. Implementation and experimentation. So the research paper said that activation functions such as sig mode, new and Gaussian are synthesized using CGP. Power function, nonlinear power function like x2 x to the power of 2 into oh, x2 x3 x to the power of 3 x3 and x4 x to the power of 4 x4 were also realized using the proposed method. Performance evaluation. The performance of the evolved circuit can evaluate based on synthesized time, gate count, and hardware parameters. It basically says that after using CGP and those stuff like CGP, we can act and AI, we can actually incorporate many things into this to make it much less time consuming, having much more like CGP just evolves these base circuits and gives you something out of it which is more efficient than the standard ones. So result and comparison reduce times and synthesize time. As I said, circuit synthesized using CGP took up to less 3 times less time to synthesize compared to traditional methods. And optimized hardware. The circuits evolved by CGP use fewer gates and achieve better hardware methods, area, power, and delay than their traditional synthesized counterparts. As I said, it just evolves your hardware, it involves the circuits in such a way that it's more efficient to actually use this. Fitness convergence. We modify CGP approach with EVR and PWF. Converts to functional correct circuit faster than standard CGP approach. This way you can actually perform much better. It can perform. So conclusion was the paper present a novel approach for accelerated synthesis of AI hardware subsystem using CGP by incorporating custom logic gate and excluding a large design space. CGP offers a more efficient method for synthesize complex non-linear functions such as those used in hardware. So yeah, this was the basic of what was uh, in the paper. So uh, what does if you so what does ASIC, application of significant integrated circuit, actually means? In it's like in it's a type of integrated circuit specifically designed for particular approach or task. Like it's made for some do something to perform a specific task, as opposed to general purpose circuits like microprocessors and microcontrollers. So, yeah, that was the ASI. The ASI in AI hardware subsystem is ASIC are increasingly used in AI acceleration, which is specialized hardware component designed to accelerate machine learning tasks, particularly in interface and training. Application of SIC is artificial intelligence, telecommunication, consumer electronics, in cryptocurrency mining. So yeah, it's used to give you uh, different, yeah, used in many places like main stuff like artificial intelligence, which is blowing up right now. Telecommunication, it always requires use of network routing, signal processes, and mobile communication. So ASI is used. A consumer electronics found, so it's like every kind of smartphone, game controllers you use, it has this. And crypto mining is because it's efficient way to uh, solving the problem of hard crypto algorithms, if you know what I mean. Uh, so yeah, that was all for today's video. If I would put my this research paper at my description, if anyone wants to read it, they can. And thank you for watching. Have a nice day ahead.